We'll pick up where we left off in the last video. I believe we were cut off, but we were looking at this example of using curly braces with the echo command and this notion again of expansion. Again, just picking up where we left off. Notice with this particular curly brace expansion, at the beginning we've got a lowercase a, at the end we've got a lowercase b, and in our output we see lowercase a and b at the end, beginning and end of each one. Now here's our variation, here's our expansion. So we're going to have a, capital A, and then a 1 and or 2. Here's our A1, here's our A2. Notice a comma separating here, so A and then B, if you want to think of it as a then. So we've done our A1 and A2, then we do B3, here's our B3, and then B4. A fairly complicated nesting procedure here. So we have these curly braces nested in these curly braces. You're not typically doing something this complicated for just a typical management of a Unix or Linux station, but you begin to see or get an idea of some of the functionality. You may create something like this, however. Let's say we change to the temp directory, and I'll just make a directory for us to work in here. So I'll make a directory of let's see here, photos, okay, and I'll change to that photos directory. And let's just say I want to make another series of directories after perhaps the name of a year, or dated after a year. So let's just say I want to call the photos, I don't know, we'll say snapshots. And well, no, actually, let's do something a little more realistic. Let's say vacation, and we're going to organize our vacation pictures, for example. We'll do a curly brace, and let's say 2007, 2008, 2009, and we'll stop there. Now let's see what we end up with here. Listing. So what have we captured? Interesting output here. Very strange looking to us. So we've got this commas and curly braces and kind of what's happened here. How's this thing worked out? Maybe a little difficult to see. Well, let's experiment here with our behavior. We've got some spaces in here, so let's take the spaces out and see if that's the problem. And now let's do an ls. So here we see a vacation 2007, vacation 2008, vacation 2009, and we see this difference just that these spaces make. Notice in our examples again, none of our examples have any spaces in them. Here in this entire expansion expression, there's no spaces in the whole thing. We do have our comma delimiters separating the information out, so the computer knows this is one piece, and here's the beginning of the next piece, and so on and so forth. So we need that type of separation to take place in order to build this. Again, look at our command, our successful command. Make directory. Everything is going to start with vacation dash, and then we're going to have a vacation dash 2007, vacation dash 2008, vacation dash 2009. Without trying to do too much interpretation here, simply stated, when we introduce the spaces in this first example, which typically we do in a comma-separated environment, at least in terms of the way we type something like a sentence. But when you're dealing with expansion, the spaces are very in this case detrimental, because the way they're expanded, the way they're interpreted by the terminal window is not going to produce the output that you want in this case. Not going to produce the output. Notice that it, in essence, included the comma and then this end curly brace, and it added all these things together. So it treats, once you start introducing these spaces, it doesn't treat this as one big expansion to be worked through. It treats this as three separate items to be created here. So in effect, what you've ended up with is a directory called this, then you introduced a space, then you got this, then you introduced a space, then you got this. This is the same thing as doing something like this, which you may have seen in one of our earlier videos. I can create three directories. Directory, create folder 1, folder 2, and folder 3. So I can create all 3 of these folders at the same time using one line of command. Notice what I've done. I've separated them with spaces. Well, in effect, this exact same way it interprets it here. We think we've done a nice little curly brace expansion, but by introducing the spaces, it sees this as, in effect, 3 different directory names to be created. Okay. Now, moving on through, talk about variables for a moment. In this case, we see this idea of a %user. This is a variable. A variable, notice here, many such chunks, more probably called variables, are also available for your examination. What's a variable? When we think about variables, variables are pieces of information that can change. Well, let me back up. In the sense of a computer, a variable is a piece of information that may change from, say, login session to login session. This %user is the variable for the username or login name of the person. So if I go in and I echo, for example, echo %user, it echoes out the user who is currently logged in at this terminal. Echoes out the user that is currently logged into the terminal. Well, there's also what we call a path statement variable. If I echo that out, this is the search path for this computer, for this particular user. The search path is merely a list of directories that the computer or terminal will look in for programs that you type in. So, for example, when I type in let's say the mkdir command, it looks in, let's just create a folder called purple here. Okay. Well, let's say which mkdir, and notice that the mkdir command or program is located in the bin directory. Well, here we see that, actually it's a little hard to see because of the way it cuts things off. In this case, we can see this here. Here's our bin directory. So it looked for mkdir in this light DM directory, in this sbin directory, in this bin directory, in this sbin directory, and so on and so forth, until it got down and it found it in this particular subdirectory. So this is just a list of places that it searches for these program or commands that we type in at the command or at the terminal window here. This path may vary from user to user. Typically it's fairly standardized. It may be a little different for like the root user account, and you can adjust this for your own personal needs. In today's computing environment, there's not typically a need to do that. But this path statement is a variable. Another variable is language. And this is a notation for English US here. But this variable could change from user to user. If I have someone whose native language is, or first language is not English, they may would set this to Spanish or French or German or so forth. And this variable, when the person logs in, would change, and instead of being English, it would be German or whatever the case may be in terms of what it's been set to. So lots of different variables that exist. You have a variable for your default web browser, for example. So if you've ever started up a web browser and it asks you, do you want to make this Internet Explorer or Firefox or Chrome your default browser? When you click yes to that, then it sets that web browser variable default to Chrome or Firefox or whatever you've set it to. So lots of different variables that exist out there. In this case, a variable always begins with, at least in Unix and Linux, it always begins with a $sign, and the rest of it is 99% of the time in a capital letters after that. I can't think of any exceptions off the top of my head to that. So again, this is a %user. You can then begin to introduce certain things, such as, echo my login name is, and then if we introduce a variable, it'll pull the value of that variable and fill it in this sentence. So we can see that use. Now, just scrolling through. I'm not really interested in this print environment command here. Let's just move on through. Look at see if there's anything else I want to hit for the sake of our time together in our short video that we've got. Again, here we see that the spaces aren't interpreted. Well, excuse me, they're interpreted, but they're deleted. Anything beyond one space is deleted. If you want to include the spaces, then you've got to begin putting things in quotation marks. Also here it says echo the total is $100. Now notice here, what does it output to the screen? It only gives me my 4 zeros separated by the dot. The reason is, remember that $sign is a special character, it's a special value. The $sign means a variable is coming. So really what it said was echo the total is and then variable 1. Well, there isn't a variable number 1 on the computer. So since there is nothing set to that variable, it didn't report anything to us. It simply echoed out the 00.00 to us. A little confusing, but again, special characters have special meanings. They're interpreted differently. In order to use a special symbol, we have to turn off the specialness, so to speak, of the symbol. And there are ways to do that. Here we see another example of how to echo out certain things to the command prompt. This is echoing out 3 different pieces of information. The current user who's logged in, we see that here. That's his username. We see a mathematical equation of 2 plus 2. Okay, here's my 4. And then we see a calc or calendar echoed out to the screen. In this particular case, notice it's joined by double quotes so that it gives me each 3 pieces of this information here. If I want the spaces in, again, introducing the double quotes allows it to take literally all the spaces that you put in. We see again some interesting variation in how it interprets double quotes versus no quotes here. And then single quotes. A little more complicated. If we need to suppress all expansions, we use single quotes. In other words, if I don't want all the expansions to operate, notice here I don't have any single quotes or anything in there. But if I go down here, they've introduced double quotes, which turns off certain things. But notice my output. Echo, here's text, here's this. We see the same thing there. Then we see, what do we notice here? With the double quotes, it did not expand. It simply echoes this out, gave me this, and then gave me this. So double quotes turn off certain expansions or special characters. If you want to turn off everything, you introduce your single quotes. So if we examine this, we see it echoed out exactly here. So by introducing single quotes, it turns off everything in effect. This is how we can escape or turn off a particular character. Notice sometimes you want a $sign to be simply a $sign, not to indicate a variable. In this case, to turn that off, we've got this backslash in front of it. This tells the computer, look, the following character, which is a $sign, usually has a special meaning, but here I just want you to report out the character in this case. I just want you to report out the character. We can do that here in our own way. Candy is, let's say, if I do $1 like this, what do you think we're going to get? We're going to get candy is then nothing. Why? Again, because there is no variable $1. However, if I use a backslash to turn off the specialness, or what they call escaping the special character, then it echoes out just simply the $sign and the 1. Hopefully this begins to give you an idea of some things that you can do with character expansion. Again, typically not needing to do anything overly complicated just for day-to-day management tasks, but it does give you an idea of the echo command and how the behavior of expansion works.